Here's something a little different.
Bob here from Hot Track RC. Whether you call this purple, violet, or something else, it definitely screams Schumacher Cougar 2 works. I know what you're thinking, Bob, when are you going to build this buggy? How about right now? If you want to see how far we get, then stick around.
At first look, the manual's nice and clear. The parts are called out by bag number and step. The bags are labeled well. And let's dive into the front bulkhead. I would say the molding quality is average. I can see variation in the surface finish, a little bit of sink, maybe a bit of warp. The arms are a little nicer. I like those. Now we have the circlips, and we'll get started putting the nut in the arm. Some of the studs thread into plastic. Some go into nuts, like this one, a lock nut. So that's nice and positive. Maybe arguably a little heavier, but nice and reliable. And we'll pop the E-clips on our pivot arms. Now, these washers have quite a bit of flash where they were stamped. And I'm going to put that away from the arm so that it doesn't dig in there. But I'll notice something here. When I put the second washer on, it sits too high, and there's no way I'm going to get the E-clip on there. Now, I could sand that down on the back of the washer and probably get it to fit. Others have reported that. I personally didn't want to spend the time, so I didn't do it. The arm fits fairly well. I'd say pretty typical. A little bit of clearance, but everything's moving freely. Moving on to the caster blocks, they are labeled for left and right. The surface finish is fairly rough and not my favorite. There's some flashing, there's parting lines, and I can see why some would mention upgrading to the aluminum alloy caster blocks. So that might be something fun to do. We need to put our ball stud. Notice this one threads into plastic. There is a counter bore there, which is kind of nice. Helps line up the ball stud before it starts threading in. That goes in snugly. This Schumacher buggy contains some amazing design innovations for the time that we're going to work through as we assemble it. And it's never my intent to take away from that. But I am going to point out some aspects of this car that I do believe are shortcomings. In the spirit of full disclosure, Schumacher is not my area of expertise. If you know of solutions to some of these issues, then drop me a comment below. Coming from the perspective of a lifelong AE builder, here's an innovation. These steering arms are built to support one large ball bearing. Usually 2 bearings are used to support moment loads on axles. But in this case, we've just got one large 8 by 16 by 5 millimeter wide ball bearing. Is this better or lighter than 2 bearings? I'm not sure, but current race buggies seem to have gone back to 2 bearings. Here, we're putting the lock nut into a keeper that will be what we thread a screw, a retaining screw, through the wheel into this keeper that presses inside the ball bearing. Because the ball bearing is such a large size, we can actually put this nut basically inside the inner race of the bearing. As a result, there doesn't need to be any external rotating shaft. Now, here's something I don't really enjoy with this kit, and that is all of the Phillips head fasteners. And I know what you're going to say. You're going to say, Bob, you love Phillips head fasteners. You replace all of the hex screws on your RC10s with Phillips screws. Yeah, I know. So what's the difference here? Well, these are mild steel plated fasteners. They're kind of a number 1 Phillips size, and they just don't go very well and strip out really easily. You've got to have a good screwdriver. In any case, this looks like a nice assembly here. We've got our keeper plate installed, and we're ready to put this in the caster block. So let's pop this retaining ring on here, and we'll get that going. Now, again, back to the washers here. Again, these are the same washers with that stamped lip on there that's taking up more space than I believe was designed by the engineers of the kit. So we're going to have the same problem here when we try to put that top. But before we even get to that, we got an issue with the steering arm binding on the caster block. And I think that that's because of flash and just some imperfection in the molded part here. So we're going to pull this back apart, and we are going to try to determine what surface is rubbing. It's not the faces. It's not that there's not enough room in here for the part, but these edges, this is actually not a functional side, but I'm trying to clean up anything I see that doesn't look right here. So there's some flashing there. Here's the edge that I think is causing the problem on the inside here. There's some flash on that parting line, and then around the face here needs to be cleaned up. So we'll see if this is the issue or not, but we'll try to get it as good as we can. And again, these caster blocks, I think, would be a candidate for an upgrade. All right, now we've got that back in here, and it's definitely better. There's a little bit of interference. It's very slight that's going to run in. You can see here, I didn't change the height, and we've got a little bit of play there axially along the hinge pin, so that's not the issue. Anyway, back to the washer. That's not going to fit. I'm not going to try to sand that down. If you do sand that down, just keep in mind that you will remove the plating. So now that washer could corrode a little bit. In any case, that's going to work just fine. Everything's turning freely. So let's move on to the Bellcranks. The center link, again, is a little crude looking out of the mold. Some modeling and rough surface finish. The arms themselves look really good. So I don't know why these are seemingly out of a different mold or a different design. And make sure here that you get your washers set so that the rough sides face each other. The manual actually calls that out. So kudos to the manual. We're going to put the smooth side against the plastic and the rough side up, and then we're going to have a second washer that sits down on that with the rough side down. That makes sense. So now we put our first arm on here, and then we have a little hat nut, and it's got a hex on it. It's not a lock nut. So one of two things. We either need to get this very tight, and we need to use Loctite, but not get the Loctite into the rotational portion of this linkage. Now, I put way too much on there, but I'm not really sure exactly where I can have the Loctite and where I can't. So the manual doesn't really talk about this. I did my best, and I think, if the rotation occurs there, it'll break any little bit of Loctite free that maybe is in the wrong spot, hopefully. But we need to get this to where it rotates fairly freely. Now, you can't just torque these down as much as you want, or they do get a little tight. So I think you have to use Loctite here. Anyway, I'd be checking that occasionally as you're running it to make sure those aren't coming loose. Finally, we'll put our ball studs in the end of this linkage, and that goes fine. Here we're going into plastic, and it's nice and positive feeling. Next up, we have some really nice ball bearings for the Bellcranks. Don't forget these crush tubes that support the load when you tighten the screws down so they don't crush the bearings. But these ball bearings won't stay in this arm. They fall right out of these holes. So I'm going to have to put those together during the assembly process. It wouldn't be that difficult probably to put something sticky in there to retain them, but I didn't go to that trouble. Now, here's something kind of unusual, a flathead countersunk screw. This is really going back to the 70s, which is even before this car was designed. And here's a little hat washer. That little step needs to be toward the bearing so that there's no friction against the outer race of the ball bearing. So make sure you get the orientation there correct. And it shows it in the manual fairly clearly with a cutaway. Here we have this other bulkhead piece. These nuts are not lock nuts that go in there, so that's going to require some Loctite. They do have the relief here to fit over the chassis steps from the countersinking process, and everything kind of positions fairly well there. But I'm doing something out of order, and you'll see in a moment that these bell cranks have to be threaded through the bulkhead before you put this assembly together. Otherwise, I don't think there's any way to get it to go. Certainly not without bending some things, which I don't want to do. Now, these Phillips head screws go pretty easily because they're going into non-locking nuts. You're going to need Loctite there. Okay, so here we go. Bell cranks. How am I going to get through that? Come on, figure it out. It's one of those puzzle games, but this one's got me. I don't think it's worth trying to get it in there. It's not going. So back apart we're going to come, and then we got to get it to sit right down like that. But even after I take this apart, I still get it wrong, if you can believe that. All right, so I'm going to put this in here. Okay, sits right like that. Makes sense. Let's get our Loctite on. But it's not going to go until I weave the bell crank through the feet of this bulkhead as such. Now I'm in position, and I can drop the assembly down on these fasteners and hopefully tighten everything up with the Loctite and be in place. If you've done these Schumacher Cougar 2s before, I'm sure none of this is very surprising, but you're seeing this through the eyes of a first-timer. Now, since those bearings didn't sit in place, we need to get the screws for the bell cranks worked into position and then set the components on those screws. And you kind of need to do both sides because I don't want to have to lift these up and over from the one side, maybe knock the other side off. So I've got all that on there. It pops right on. Okay, we should be good, right? But now I'm trying to get the screws to go through, and no luck. It really doesn't seem to want to go. So I take the screw out, and it won't go in from this side either. The hole through this bulkhead is just too small, or it's got a lot of burrs and flash on it. Luckily, I was able to clean this hole up without disassembly. I used an 1/8 inch drill bit, and it matches the size of the screw almost exactly. So I didn't over drill it, but I just ran it through here by hand. There wasn't a lot, but there was some material that was removed, and then I could easily pass the screw through. Now I can go back to stacking up the components there. I'll put the hat washer on with the bevel up, and then the ball bearing on one side, do the same on the second, but now the screws fall out because they actually fit, so I got to hold those in place with both my fingers, and finally I can push the screws through, add the crush tubes, the upper bearings, and then we'll put those beveled or hat washers on with the step facing the ball bearings to make sure we don't have any friction. And got those on there the right way, both sides, and the nut goes on. And that's a sense of accomplishment right there. All right, now let's tighten this up, but not too much. There's, I got to go to the flathead screwdriver here. Very easy to let that slip and scratch your pan. Be careful. So let's see how tight we can get this. Those are lock nuts, which is good. Got to do the bottom side here. This is a little awkward again because the flathead screwdriver doesn't center itself. It could slide out either way. So now when we get this marginally tight, feels pretty smooth, so I'm happy with that. Let's check out this really nice looking front shock tower, all carbon fiber. Look at all the adjustment holes for the upper shock positions. This seems to be an upgrade part for the Works edition, and it will keep you busy at the track trying out all these positions. Now here's one of the few fasteners on the car that uses a hex drive cap screw. And for some reason, I didn't even feel the need to actually engage the hex. I was too busy tightening the jam nuts against each other with my nut driver. And now we'll put the ball stud on here, which is a black oxide finished ball stud with a lock nut on the back, 5.5 millimeter. Both of these fasteners use a 5.5 millimeter, so it's handy to have a nut driver and a second wrench. This is a good looking unit. This is an interesting bulkhead setup. There's a gap between the two pieces, and the front bulkhead kick-up can flex. So you have to fill in that space, and it seems like depending on the spacing you used, you could affect the kick-up angle. This doesn't feel too robust yet. All the structure is going to be in these fasteners linking the two pieces together, and those spacers that we're going to insert here, which is a little bit awkward. It takes 2 of them per the kit, so you need to drop those in the space, work the screw up a little bit so that it'll center and allow the second spacer to drop on, so have a little bit of the screw protruding. Now there's a little bit of clearance still, but we're going to tighten the screw down and make that go away. We'll get the second spacer on the other side. Now, these don't just drop straight in. You kind of have to manipulate this a bit, right, to get it to line up. And then it will go, there I got it, to rotate. And now everything will lock into place really well, and it feels quite solid when you tighten this down. Again, we're using a Phillips head fastener, whereas the upper shock tower mounts are hex, which is nice, but I didn't get to enjoy that very much. And so now this is locked, and you can see the spacers in there and the structure. Unlike an RC10, there's no aluminum nose piece. It's all plastic. And there's some empty space here in the front, but that'll get covered up by an independent body piece that'll be painted. That should look good. Time for the ball cups. Now, I really like these. These are robust, more modern feeling ball cups. They have a little counterbore to get them started on the turnbuckles. They're beefy. They fit really good, and they spin on easily. They're not super tight. They're going to adjust well. The manual says to use a little grease. I don't even think you would have to have it. It tells you what spacing, so I'm going to adjust to that, which turns out it's pretty close to a good setup. I always spend a lot of time measuring, but really just pop them on the car and you'll adjust it later. So here goes the steering linkage. Of course, the Bellcranks have their own center link that is non-adjustable, which is just fine with me. Don't really need that. And these are kind of a unique geometry for the Bellcranks. I don't know how you would know how to space them anyway. So again, these ball cups pop on really nicely. I could do this with my finger, but for some reason right there, I didn't feel like doing it. It's kind of the angle of attack that you're at. And that looks good. Everything's turning freely. Now we can put on our camber links. Note there's a larger radius on one side of the adjusting square on these turnbuckles. That is on the right-hand thread side. So put the larger radius on the right side of all of your linkages, and then they'll always adjust in one direction to make them longer or shorter, making things a lot easier to deal with. So now we've got our geometry, and everything's floating and moving and rotating, and it's looking good. We're moving rearward on the buggy, and next up are our servo mounts. And they're this L-style design, which at first glance seemed okay. And then we're just going to use some fasteners. Unlike the AE parts, these don't thread into plastic, which also seems fine. And they have some adjustability side to side. Next up is the servo saver, and we're going to choose the one marked for Futaba. It has the right number of spline teeth, but I found this to be rather vexing. First of all, the mold quality here is not great. It's different surface finishes, a lot of flash, and the kind of sharp edges. This spring is supposed to slide in, and the manual shows that it goes in like I'm putting it in, not like that, and then it flips over. If you look in the right picture there, it goes upwards, and then you're supposed to rotate it. There's some arrows. I really can't figure this out. I'm sorry. I'm sure that there's a simple explanation. I kind of think it's just supposed to be put on like you would expect, not the way I'm doing it, because there's no way to sort of bend it down. But no matter how much I looked at the manual and looked at the angle of the feet, The tangs on the spring, I could not get it to match. Now, when I put it in the simple way here, there's lots of play between the hub and the arm itself. I didn't like that. The fingers on the springs are splayed outward, and it doesn't fit tightly. And I just came to the conclusion that even if I figured out how this is definitely supposed to work, I don't like this part. So I'm not going to use it, even though I'm really kind of stumped as to why I'm not getting the same setup as in the manual, and I want to figure it out, but I'm not going to. So in any case, I'm moving on. Here's the servo. It's a ProTech. This is the same servo I used in the team car. As I said, I'm setting those two cars up the same. Here's the servo horn that came with that servo. I'm going to use that. The thread is correct for the ball studs, so that's nice. I don't know why I put this nut on the backside. There's really not enough thread protruding, but I do it anyway. I put a little Loctite on here. So that was a tough one. I should have just left the thread sticking out the back of there, but it'll probably stay on with the Loctite. So now I got to find the center of play here for the servo. So I typically just rotate it around since I don't want to bother to set up the whole radio system. And you can find it pretty close to center that way. Now I will put in the servo horn retention screw, and there's a little screw that comes in from the side. Now, I should be using Loctite here. So a lot of these screws come with Loctite dry lock on them. This one did not. So I should have put Loctite on there. And then there's a little screw that goes in the side and clamps. This is a nice feature on all the modern horns that really removes any play between that servo spline and the horn, which is a nice feature. But now I get into this situation that I don't really understand. Okay, I'm going to use these little grommets that came with the servo. They fit really nice into the servo feet. But when I put this together, it all goes, but I'm kind of surprised that the servo sits up quite high off the bottom of the chassis. And there's not really any easy way to fix this because the servo feet or flanges sit on top of the L feet, and that's just the way it is. I look at the manual. They're not. You might think that the L's are installed backwards. They're not installed backwards. If they were flipped around the other way, if the holes were in a different position, it could sit down flat, but they're not. So I don't know really what to do about that other than to just tighten it down and go with it. But I really feel like the servo mounts are an opportunity for improvement, and you can see they rock quite a bit there. They're not very stiff, so all around I think that's an upgrade opportunity. Now, putting the linkage on here, that's nice. Everything moves smoothly. So I think that's going to be good, but again, now the angle is a little high. Yeah, the arm could be shorter, but still, setting that servo down on the pan is going to make everything line up better. Anyway, I'll adjust the length a bit and get it all centered, and that looks good. Time for the rear bulkhead. This part has some shiny surfaces. There wasn't any micro texture put into the mold, and then some modeling look to it. So I don't find it super attractive, but I think it's going to be buried under a lot of other components. These are the pivot blocks for the rear arm hinge pins, and this is really advanced compared to the RC10s of the time, allowing for a lot of setup adjustment. But I don't know how they work here, so I'm trying to push the pin in after I put the screw through the block. You can't do that because the screw locks the pin in place. A really nice little design, nice engineering, where now once the screw goes through, that pin is locked in place. And then I can stick it up through the chassis, and I can put different spacers in there, get different angles. Now, the only thing I would say is the surfaces that these pivot blocks engage are not super precise spots on the stamped chassis. That's particularly true for the rear mounting block, which attaches to the side of that sort of bent surface on the chassis. So I feel like there could be some variation from side to side. You can clearly see the anti-squat angle there. I really like these rear arms. The skeletonized design is cool, and I believe an upgrade for the Cougar 2 works. But in any case, they're really nice. Now, these ball studs thread into plastic, unlike the front. Per the manual, we're putting these in the innermost hole. Just one ball stud. It's even cooler looking. Now we have to cut out our spacers, and they're stepped in different sizes, which are called out in the manual here. We want the 1.5 millimeter, which is the second from shortest. That's going to give us 4 degrees of toe. If you don't have flush cutters, get a pair. They're only like $8 on Amazon. They're really nice and super handy for cutting parts off trees like this. Now we get to slide these arms on the hinge pins. That just feels like a performance setup right there. That is cool. Next up, our rear pivot block, and just making sure the orientation is correct here. First, we'll thread the screw from the inside of the pan, and then put our toe spacer in, and then weave that through the pivot block. Despite how cool this design is, I do feel like these blocks are a little lacking in the robustness area, and they do make aluminum alloy pivot blocks you can get, so that might be something to check out. Now, if I can just line it up and get it in there. Okay, now we can put a lock nut on the outside, but we've got that Phillips head there, and you can't even put a driver in straight on that, which I don't like that. And when you want to take your arms off, you got to take your transmission out, I think. Correct me if I'm wrong. Drop me a comment below. So anyway, the serviceability on that doesn't seem ideal, but it goes together, and now we've got 2 arms on the back of the car, and they are quite adjustable. The rear shock tower is not as tall as the front, but it's going to nest into that rear bulkhead. We've got those same nice cap screw fasteners for the upper shock mounts, and we'll have a jam nut setup on these as well. And I used a hex driver on this. That's cool, and it feels really good. I got that nice and snug. Hey, look at me going back for more. So that's enjoyable. I'm glad I got to experience that on the rear. I didn't do it on the front. Lock those jams together, and you should have a really robust mount. And now we'll slide this in, and then I noticed something, that there are 2 positions, which is very innovative and cool, that you can adjust the whole shock tower to. I've tried to do that on an RC10 before. I actually drilled extra holes so I could do that. Led to other problems with the dog bones, but tale for another day. The camber studs could thread into the bulkhead hole there, but they don't. They slide through clearance, and they use a lock nut on the other end. I'm good with that. I've had ball studs tear out of holes like that on RC10s, so I can certainly understand why this would use a backing nut, and that's nice and secure. So now we'll put on our camber links and make sure the large radius is on the right side, just like on the front. Time for the diff. Look at these balls in this thin bag, just mixed in. That seems dangerous to me, and they do not give you any extras, so be careful. Now we'll put our diff nut in this plastic T housing, and then just push down a little bit with the flat surface of my needle nose pliers to get it pressed all the way in, and that will go into this yoke, and that has a castle on the one side. The rear end of this buggy is super cool, if not a bit over-engineered, and here we are with these large ball bearings again, which are super robust. They're never going to go bad. And we got the flange for the diff. We got another bearing that goes in there. And then the castles fit together. So now we have a hub and a disc. I noticed the surface finish on these diff rings is a little rough. The gear pops on that flange. And now we need some diff lube, which I'm going to put into these pockets, and in preparation for the balls. That way, when I put the balls in, they will sit right in there. They're not retained, they just drop in, and you kind of have to put this halfway together, I believe, before you put these balls in here, as I am doing here. Now, these balls are magnetic, unlike some of the recent AE balls in diffs that I've built. Just drop them in carefully, one at a time, and you'll find that you have the right number. In all these cars that I've been building, I have yet to drop or lose a diff ball. Knock on wood. I can't believe it hasn't happened yet, and now it definitely will. Now, here is our thrust bearing. This looks a lot like some AE thrust bearings. And then this little washer here is conical. There's actually an angle on that. It's a miniature little Belleville washer, and that's going to be our spring, 2 of them back to back. There's not going to be a lot of travel or adjustment distance, but honestly, it seems to work okay. But here we go with our little thrust washer. If you notice there, though, all that is stacking on top of a flathead screw, which is kind of interesting. Not the hardware that I would have chosen, but it's working. So now we will grease up both sides of our thrust washer here, and make sure when you put the washers together that you put the groove side toward the balls. And now we will thread that through the other yoke. And flathead screw, that's our adjustment for this diff. Kind of astonished there, but just be careful with it. Don't strip that flat. And here goes our bearing. And then we will put the other flange in, and the flanged bearing, and the other diff hub. If you put some diff lube on the backside of this diff ring, it would stay in place. Instead of doing that when you try to assemble it, I sort of cheat it here and get it to go and stay in place and pop everything together. Now we need to thread our diff screw into the nut that we started with, and just make sure everything goes together without cross-threading. And then you're going to tighten this all the way down. There's not a lot of spring compression, as I mentioned, but actually there feels like more than you would expect, and that feels good. Now I'm going to make sure I've got it all the way collapsed, and then back off a quarter turn, something like that. And now, how does it feel? It feels good. I'm happy with that, and that's a good looking assembly. Of course, what we're looking at there is a timing belt pulley, not a gear. Now, time for the drive shafts. This is what we've all been waiting for. So we'll start with the little T shaft there, and we'll put some black grease and coat that so this bushing can ride on that lubricated surface. And then something I wish I would have done here, that gets backed with an O-ring, is to put some grease on the pins before I put those rollers on there. I don't think the manual calls it out, but I should have done that. Now this is captive inside the tube and slides down in there, and you can see that those rollers can't get out. These slotted drive components will transfer torque from the rollers inside the tubes and allow the drive shafts to telescope, eliminating the need for dog bones that would allow movement. So there's a cross pin here, and then O-rings retain the cross pin, which is a nice, simple way to do it. It's positive. And then we'll put some black grease in the slot here so that the rollers have something to lubricate them. And just wish I would have put some grease on those pins. But nonetheless, we'll slide these together now. But then I find something that I'm unsure of because the manual does not specify. Clearly that's supposed to be pushed together to where the yoke goes flush with that aluminum tube, but it's quite tight. It does not want to just pop together. So I go on to the other side here, and there's another cross pin. Put that yoke together and the O-ring to retain it. And now we've got a cool looking assembly, but I got 2 telescoping sides and I only should have 1. So clearly that is the side that we want, and I was able to pop it together by just applying significant force. And it's difficult, so just buck up and push the thing together, and then you'll have that. And it's really cool looking. And here we are at the infamous U-joint assembly step. Well, first we just need to put this nut in, which is going to be what our fastener for wheel retention screws into. Now I've got the secret here for putting these U-joints together. Heat. Make sure you get these nice and warm and then jam this. See, I didn't know how to do it right here. I got to get that spider into the first side. So get it hot, push this in to the first yoke arm all the way. Now I got that in. Now I can use the tool to flex the arm out and then push it down. Flex it out and then push it down. And then you're in. Actually, now getting the second half on is a little bit harder because you can't hold the spider. So get it warm, and then you got to get this lined up, but now it flops around on you. You got to use your finger there. It's kind of a pain, but again, same thing. You got to push it in, and then we can use the tool to flex the other arm out and then push down, and it'll pop into place. And actually, when you get good at this, it goes pretty easily. And boy, that is awesome looking. So now on to the next side, and you got to push that all the way in. Now use the tool. Don't try to use the tool until the first pin is in, fully in. All right, and let's see if I can do this easily. Bend it out, push it down. I made that look too hard, too hard. Come on, Bob. You can do it. There it goes. Okay, now we just need to pop the other piece in. Again, this is a little trickier, but I'm getting better at it. And obviously I'm still heating this, but I'm not showing it. And that went right in. And now we have the whole one side complete. It telescopes, it pivots. Super cool. And there's the entire drivetrain. Look at that. Onto the top shaft. Now, this flange hole is clearly off center. I don't like that. I think maybe it doesn't matter because it's just a flange. That's the pulley side, and here's our top shaft with all these cross holes. We need to put that pin in there, and then it will be captive inside this pulley. And just make sure it goes all the way in and seats, and now the flange side pushes in, fits somewhat tightly, and it transfers torque. And so then we have this ring, which has a chamfer on one side of it that goes against the radius of the pulley. Here's our casing for our transmission housing and the aluminum side plate, one of the two. Now, here we have a lot of Phillips head fasteners going into plastic. You know, just apply pressure. The whole time you're driving these in, you need to be applying pressure. Otherwise, they're going to round out on you. So it helps to have a good Phillips head. The one I'm using has a rather small handle. Be nicer to have a bigger handle. Now, the bearing keeper has these strange markings on it, and I'm sure some of you know what these mean. It didn't seem to have any reference to the orientation. I could put this in any position. The manual was not clear about that. So I'll have to make sure I'm doing it right. Anyway, these two screws go into this plastic housing, but the lower two are going to screw into the aluminum. So they're different length screws. So you got to pay attention to this. On the outside, they look the same. I must have rounded out one of the screws a little bit there because I had some metal building up in the head of my screwdriver. And now for the short screw. Now we're going to put this cross pin in on the top shaft, which is going to ultimately transfer torque. And then there's a little hat on the other side, our belt, which needs to go in here. Now look at that. The adjustment for the diff is buried under that U-joint. That seems really tough. If you want to adjust that, you got to pop that U-joint apart, I think. Now I'm orienting the adjuster on the same side as the slipper clutch. And then we're going to feed it through the side plate here. And now I've got a view here. Now, it looks like this belt is going to rub a bit on the housing. Maybe when it's tighter, it won't. I'm not sure. And then here's the keeper for the other bearing plate. And then I'm going to drive the screws into the second side. Again, these are all going into plastic, and they go in quite a ways. So just take your time and hold everything together. Anyway, I would definitely prefer some more positive fasteners for this. Again, those are going into plastic there, but then the lower ones are going to go into the aluminum. Those are the short ones. So I would prefer that the side plates were tapped instead of self-threading. I end up taking this apart a bunch of times, and that starts to become a little concerning that you could strip out the thread there. All right, now this is the eccentric for adjusting the belt tension, and per the manual, you're supposed to put that little arrow pointing just above the screw head on that side, and then you install the keeper screws there. So that's coming together. Now, this is where I was a little tired at this point and realized I have to do a lot of cutting on this gear cover because it has two halves. And this is the inner half, and then I've got to cut all these pieces out. So I get out my reamer tool, start making all the holes. There's a lot to do here. And no one tool does it all. I'm using some little scissors. I used a Dremel. This took me a long time. I spent like an hour on this and the mating part and getting it all fitting perfectly. So take your time. One thing that I found here is while I got it to fit over the bearing keeper okay here, after I cleaned it up, I'll see that it's a little bit off center, but more on that later. Now, these washers are going to have that stamped sharp edge on one side. Put that away from the plastic or it might cause a crack. So I'm lining that up carefully. Again, these are threading into the aluminum, I believe. And the other issue here is they're going to be hard to get to in a minute. But in any case, it looks good. Now, to put the little washer for our bearing on our slipper clutch in, they give you a screw that's just designed to press it in. The two washers of this thrust bearing are different diameters. One of them will fit loose in this slipper clutch flange, and the other one will be tight. So make sure you get the right one. If it falls right in, it's not the right one. Now just use the provided hardware to tighten this together, and it'll pull the thrust washer right into place. And ironically, this is again one of the few pieces of hardware that's hex drive. So it works really well and takes a second, and then this will all come right back out. But that thrust washer will remain in place, and that is embedded in there, and it's not coming back out. So now we can take the other half and install it into the transmission. And then we've got our slipper pad that sits in the retained side of the slipper clutch. And now we will put some grease in here on the thrust bearing for the slipper. And drop that in and get some on the other side of the washer. Again, remembering to put the correct groove side toward the balls. And here goes the spring, along with a washer and a nut to adjust everything. And then something popped, and I wasn't sure what that was. That kind of scared me there. But everything was turning smoothly. Don't see that anything has disconnected, so I went on. And our spur gear here lines up with the two screw holes. I think Loctite's going to be a good idea on that. These are Phillips again. So you don't need much torque on this. It actually works fine to be Phillips, no problem there. But now something is rubbing. And when I look at this, the spur gear, it's really close to the one side of the cover. And so I'm suspecting that that could be the issue. And I certainly like to center that a little bit better. But to disassemble all this is a bit of a pain. I think I can drop the housing a little closer to the eccentric, but I have to get this slipper disc off. And I think that's what popped on. And now it's very tight. So how do I get that off? Well, I managed to pull it off. It's not pretty. I used channel lock pliers. Now, you might think that is a horrible way to do it, but it's very hard to get in there because of that plastic housing, and I did not do any damage to that slipper. So anyway, now what we'll do is we'll cut more on the top of that square so that this whole cover housing will slide down further and be more centered. So I did that. I removed some material, and now it is closer to the eccentric, and hopefully that'll do it. So put all my screws back in these self-tapping threads in this aluminum, and put the slipper back together. And what is this? I don't even have the gear on yet, and it's scraping. So what is scraping? I mean, it's almost as loud as the birds chirping, so that's a problem. And what I see is that the slipper, the back of the slipper, is touching the fasteners that hold the bearing retainer plate in. And it's definitely hitting. And I have a lot of axial play and movement in my top shaft. So if the top shaft is pushed away, it's okay, but it can slide in it and hit those screws. So now I'm going to pull that off again, and you'll witness that. So what do I do? These screws, they're seemingly lower than the flange there, but actually the back of the slipper clutch has a relief that sits down. So now you can see there's some play there. This bearing could limit the movement more, but it allows all that motion back and forth. So we're going to put a little shim in here. And I'm going way off script here. This is just me. I made a little 4mm diameter spacer shim here, and we'll see what thickness we actually need. It's a tight fit on the ID, doesn't need to be, but I got tired of reaming it out to make it fit. Now, it's a little too thick because I can't put this housing all the way down flush to the side of the transmission casing, so I need to remove some material here. What am I going to do? Well, I'm going to use this hat actually as a holder to then file it down. But actually what I did that worked better is I used some like 150 grit sandpaper. And then I was able to take this down. There's about 25 thousandths of an inch thick. So now I can reassemble this and see, do we have the right clearances? And we put the bearing on here and the keeper. We'll find out in just a second. Now, that's getting there. That is very close. So let's screw it on together and see if we like it or not. Again, I've taken these in and out quite a few times now. And that is perfect. I have a little bit of clearance, but it's nowhere close to touching those screws. And voila, I turn it, no noise. Very happy. Now, my centering here is better. The spur gear is not so close. And here's our transmission going onto the pan. Yay! And there's some screws that go through the back of the bulkhead, or maybe that's the front of the bulkhead, into the transmission, and then the bottom of the pan, of course, up into the transmission. 4 screws, and this is the fun part. Boy, we've worked hard to get to this point, and I am enjoying every moment of this. Careful with my fasteners. These are all Phillips. This is going into plastic, and now we're really getting somewhere. That is looking good, And we put our little rear bumper protector motor plate on here. Interestingly, it only has 2 screws on the bottom, and the top side just has a little edge or lip that sits against the transmission. Let's put together our hub carriers. Oh boy, I am ready. Now, these are tiny little E-clips, and 2 of them were in this bag, again with the rest of the hardware, and I didn't see them hiding behind the label, so be careful. I like these hub carriers. This kit is really interesting. Some of the molded parts really are nice, and others are okay. So I like these. Nice molding, and they look good with the studs, and in this case, we're back to using a nut to retain the stud. The bearings are not super tight in here, so we'll deal with that. Okay, these slide right over our drive shafts. They have the castles on the end there. And now we have our hinge pins, which are a smaller diameter. And that makes sense out at the end, and you want less unsprung weight, so that's cool. They're smaller than any others that I've worked on in a similar location. And just be careful with the E-clips, but look at that. Everything's articulating, telescoping. Wow. Look at her spin. Now, the manual shows a black O-ring and a red O-ring of similar size, and then a much larger black O-ring. I looked in this bag for a long time, and all I saw were red O-rings, and then I realized they're 2 different size red O-rings, and so they do not follow the right color code. Just be aware. Now I'm going to take the shock cap and cut that off, and the spool. And then one little washer. The rest of this we're not going to use. But you could use these pistons that have various hole configurations, but we're going to use the adjustable ones. These use 2 discs adjacent to each other that allow you to rotate them and create a different number of holes depending on the orientations. Next, we're going to take some foam donuts and pop out the hole, and then soak this in shock oil. Now, I'm not sure. I'm thinking that the purpose of these is to create some compliance inside the shock. Basically, something squishy in there that allows the fluid to sort of expand and contract into that material as the piston rod goes in and out of the shock. I could be wrong, but that seems logical. So we'll get as much fluid kind of started on these as possible, and then we're going to pull them around the outside of these spools, and you'll see that these don't really touch anything or serve any other obvious purpose. They're a little bit tricky to pull on here, and you need 2 of them per spool. Notice that the spool has 2 tangs on it, and you'll see that that is the side that we want to pop into the cap, and it retains the spool inside the cap. But next we'll get some slime on our O-ring that will be our cap seal and work that around. I make this look more difficult than it needs to be, but you know, these gloves are a mixed blessing. It could go a little smaller maybe, and it'd be a little easier to manipulate these O-rings, but anyway, one thing about these caps that I wasn't super fond of is there's no tool for installing the O-rings, and the O-rings don't really settle down on their own. You kind of have to work them into place, so I used my pick to kind of adjust them and move them around. I just didn't want them to jam sideways. When I then put this spool in and pop it into place, those tangs will snap in there. And then we have an assembly, and like I said, that little sponge material is on the outside and doesn't really touch anything. All right, now let's build some piston assemblies. So get our E-clip on here, and then we have to work these adjustable dampers. Notice they have those different holes, kind of irregularly spaced, and then there's a little slot on the other side that fits on this pin. So you put it in there, and it can only turn within a certain range. But it's a little tricky to see and sort of adjust them to the consistent number of holes, but I've done that here. Now, I'm not really sure why this is better than just switching out the pistons. it seems to me that you can't do this without disassembling the shock, and then it's kind of a pain in the neck. Wouldn't it just be easier to put different pistons with different number of holes on those rods? Anyway, maybe somebody will drop me a comment below and explain why we might want that. But in any case, we're going with it, and we're going to fill up the shock body with oil. Notice that these shocks only separate or open at the bottom of the shock, so you can't really hang them. There are no bleeder caps on these, and you're going to spill a fair amount of oil out, so I did this over a pan, and you just work the piston in and out and let it ooze out and then tighten the cap up. Works pretty well, and maybe that foam in there makes the process a little easier. So now we're going to put our ball cups on the end, and notice these are not rod ends, but they're ball cups. And we need to put our spacers in here to set our spring preload, and the manual suggests a starting point for that. And next we'll insert our spring perch in between the ball cup and the spring, and we've got a functional shock. Feels good. And the rears go together much the same, but the spacer configuration is a little different. And kind of one of each size there. Don't forget your top centering ring. And as I start to evaluate these two rear shocks, I notice something, that they seem a bit different from each other. The one on the right there has more damping than the one on the left. I'm going to have to come back and check that out. I suspect maybe I got the wrong number of holes in the piston on one of them. So something to verify. I'll see if it's my imagination first. Anyway, the top shocks are retained by 3 pieces of hardware and a nut. There's a cup that kind of covers up those jam nuts, and then there is a ball, and of course the bottom just pops right on. Very easy to install these. So there's a cup, here's a little ball that the shock pivots on, and then a washer, a plastic washer, and it's conical, so make sure you get the sort of conical side toward the shock. And then leave a little bit of play there. Pop that right on. We'll see if these shocks tend to pop off. I don't know. Same setup in the rear, so you can get into a flow here. And I got to say, this all goes together really easily. The AE cars don't have that extra cup part. There's a partial cup and the ball are one piece, so one extra piece of hardware, but I do like the way it goes together. So, and then again, very easy to pop these onto the arms. And here again, I'm pretty sure I'm seeing more damping on one side. But let's go on to the motor, because that's fun. And here's our Kyosho Gold. This is the same motor that we used on the team car. Now, I had a broken or cut washer there, but I had extras in the set, so whatever. I've been seeing little things like that in different kits that I've had recently. So here's an extra washer, and of course, we're going to put the smooth side toward the plastic so that it doesn't cut in. And we'll get our motor set up. This slides up and down, a little different than the RC10s. Now, I found something here that you cannot, at least with this motor, you can't put the set screw on the outside because the shaft isn't long enough with where the spur gear ends up. So now the issue is you got to have either an L-arm, or you can drill a hole in the housing cover, but I didn't do that. I just used an L-arm to tighten the set screw, which worked okay. And then we'll be careful and adjust our clearance, our backlash, so that we have just a little bit of rock between the gear teeth. And that looks very nice. I mean, I have no complaints about the aesthetics of this car. Now, this cover goes on, but there are no supplied fasteners. The manual suggests using some tape. So there you go. Time to install our battery retention system. First, we're going to start with these nice long set screws. They're going to screw into the top of the 2 shorter towers. And we're going to choose to put these in the front position just because I think weight bias is better to have far forward, especially on carpet, which is where I'll probably run first. So I'll put the short ones with the set screws up there. These are nice parts. I like these molded parts. I know you can get these in alloy too. I don't really see the need for it. And I think these are a little lighter. So now here's our retainer, and it's got some little stops that you screw onto the ends, and then some thumb screws. And I would say it's a little on the tall side. This is for a full capacity battery. Oh boy, we're getting down to brass tacks now. Here are the tires. These front spikes look like they'd be good on grass, which I know is something that's common in Europe. And then the rears, they look closer to what you could use on a carpet track, but probably good on AstroTurf. So we'll just pull these fronts over the front wheels. And it takes a little effort, but they go in okay. Pay attention to the orientation of your wheel. These are a little odd looking. Remember, we're going to put those discs over these. Now we'll work the bead in here. The sidewall should drop into the bead until it's right there with the lettering. And this side did it pretty easily. And then when I got to the other side, it didn't want to go into the same spot. It wanted to stay out a little bit, but you can see here how it goes all the way in there, and the lettering is like right on the rim. The back side didn't have any problem with. Now the second, like I said, it didn't really want to pop in. And if I had started with this side, I think I might not have known, but I did work it into place. The rears I had less of an issue with. They pretty much snapped into place, and they look good. Just work the bead around, make sure the foam's not stuck in the bead, and then I like to roll them on a little bit. And here we go. We've got our fasteners, and these are screws that are going to hold these wheels on. Let's snap our discs in place. Now, the castles engage, even on the front wheels, even though they're not driven, they hold the spindle that the nut is in place relative to the wheel while you tighten everything down, so it's kind of mandatory. Anyway, the rears go on, and of course they're attached to the drive shafts, so the castle's actually transferring torque on these. You don't have a real positive feel like when they snap into place on the castle. Just tighten them down. And here we go. The suspension is working. Of course, there's no weight in the buggy other than the motor, really. Everything's smooth, no binding. And this is a really unique looking buggy. I'm excited to have this in the collection. It's different, and it has so many design innovations. I think it's going to be really competitive with the team car at the track. There's only one way to find out, but until then, it's going to look great on the shelf.
And here it is, the Schumacher Cougar 2 Works. And what do I think about this buggy? Well, it's an amazing vehicle with all kinds of innovations, from the telescoping rear drive shafts, the rear arm mounts with all that adjustability way ahead of their time, the innovative Bellcranks, the shock design, and a whole host of other features. I do think that the fasteners let the car down just a little bit. The Phillips head mild steel zinc plated screws are all self-tapping. I'd like to see more machine screws with hex drive. I don't love self-tapping into aluminum. I'm used to seeing those pre-tapped and using machine screws. But does that take away from the overall vehicle? No. This is an amazing buggy in the assembled state. It's awesome. I can't wait to see how it does at the track, and I'm so excited to have it in the collection. So what are we going to build next? Well, I don't know. We've got a couple buggies that need to go together. This needs to get to the track, so I'm really not sure what we're going to do. But if you want to find out, then we'll see you next time.